Why is lowercase
Well,
e
that's the
momentum?
same
Because it used to refer to a concept known as emphasis, and so that's why they use the letter P.
Mr. Bubby said we're just gonna do the computer thing another day. So you,
Okay, all right,
Is it just those two?
yeah, just grab those, take those back to it.
You guys
It's a
are lucky.
Monday of disaster. Okay,
Maybe we should.
So that's
That's
why
why
it's
my
lowercase
Google
p.
wasn't working. I'm
so
gonna get to play Clash today.
when you look at,
Start the camera.
is the camera going?
Yeah,
Yeah.
it never got shut off.
Okay.
I did shut it off.
So, when you look at these questions, okay? So, when you get specifically like to question number 6, and you got two different graphs. You're gonna have a net force versus time and a momentum time graph. So, here's the story. So if it's net force versus time, there's two shapes you can have with this. One would be a horizontal line, and in that situation, you're assuming that the same amount of force is being applied over the entire time interval, okay? So if it says like average force, or this is the force, that graph is just a horizontal line, it's a rectangle. So then, when you find that area, oh, that's simple. That's force net times time equals change in momentum. It's just a rectangle. So when you look at force net versus time, all that is length times width equals the area of a rectangle. That's all it is. So at number 6, that area, oh, that's change in momentum. Now, when you talk about the slope of a momentum time graph, that's something different. So, since this is momentum versus time, so again, think this through. If it's a horizontal line, that just means that your momentum is constant and your momentum isn't changing. So if your momentum is constant and it's not changing, that means that your velocity is constant. That means that you're not accelerating, okay? So, a horizontal line on a momentum time graph is analogous to a horizontal line on a velocity time graph. So if you have a horizontal line on a velocity time graph, that just means you're not accelerating. It doesn't mean that there aren't forces acting on the system. It just means that you're not accelerating. So the same thing is happening here. So when you have a horizontal line on a momentum time graph, it doesn't mean that there aren't forces acting on the system. It just means that all the forces add up equal to 0. Now, this graph could also slope up. Okay, cool. That means your momentum is now changing. So if that happens, this momentum is in Newton seconds. That's the easiest way to do it. You can use kilograms meters per second because it's mass times velocity, or you can just do Newton seconds because it's force times time. So if you look at that change in y, change in y over change in x. That's Newton seconds divided by seconds. The newtons cancel out. Hey, that represents your net force, okay? So force net time, change in momentum, area. Slope of a momentum time graph, that's your net force, because that's creating a change in your velocity, that's creating a change in momentum, that's creating an acceleration. So when you get to question number 7, okay? You got a 30 Newton force acting over 0.16 seconds, okay? So all you have to do on number 6 is draw a graph that looks like this. Here's 30 Newtons, here's 0.6 seconds, boom, there you go, okay? That's all you have to do. Do not make it complicated, it's just a horizontal line, that's all you got. Now, when it asks for the impulse, okay, remember, impulse means the same thing as change in momentum. This is why it's technically known as impulse theory, if you really want to get nerdy, okay? This is what's known as impulse theory. So, you have the force and you have the time. Literally, all you have to do is multiply the two numbers together. Do not make it complicated. You're just finding that area underneath that line. Okay, that's all you have to do.
Right.
So then when you get to number 9, hey, what would have happened to that change in momentum? Okay, well, if you go back, all you're going to do is you're going to take this same line and then you're going to extend it out like this for twice as long. Oh, okay, right? Same force applied for twice as long. Miracle of miracles, the change in momentum is going to double. Okay? Cool with that. Now let's talk about number 13. So number 13, there was a time that we refer to as BW, which stands before Walmart. Okay? Yes, civilization existed before Walmart and before Amazon.
What?
I know, shocking as that may be.
I
Wait,
thought
what are we talking
Walmart's
about?
where they got like,
Target's
Number
better.
13.
where they get groceries before Walmart.
I know that, well, shockingly, some people grew their own food. Shocking.
You can do that?
You can't, that's legal.
That's legal?
Yeah.
Well,
So on number 13, so let me kind of give you the historical background on number 13. So, like when I was growing up,
you lived in
Wow.
BW?
oh, absolutely, I did.
Dinosaur
Whoa.
What's
times.
BW?
There,
Before
before
Walmart.
Walmart. Do you
He just
not
said that.
listen to what I say?
Not even a minute
I
ago.
was wrong.
The way he shakes his head so confident.
Kevin, I want my calculator cover back now. Honestly, after that,
Okay.
Really?
yeah.
Anyway, back
Mine's
to our
better
story.
anyways, because I was.
So, I grew up in Cheney, and I would remember riding into town with Dad, and
They had
he had, there
cars.
was just like a bench seat in the pickup. And the whole concept of child restraint seats did not exist. Like literally, number one, there wasn't a Walmart. Number two, you couldn't buy a child restraint seat if you tried. They weren't built. So I would literally, so here was like a seat. I would stand up beside Dad, driving down the road at 70 miles an hour. Okay,
Like-
no seatbelt, nothing.
Was it a Ford or a Chevy?
Ford.
Oh,
Like
you're
you
fine.
would stand in like on the seat.
Yeah. So I would, you just stood up there. That's what, and then when Dad would hit the brakes, he'd put his arm out. You know, okay, I'll slow you down. And
My
you
mom
could
does that.
always tell instinctively, people that were parents, like even after their kids were older, when they would hit the brakes, they would instinctively just put their arm out to try and keep
My
the kid
mom
from
does
turning
that.
into a projectile. So when you get to number 13, let's start off, because if 13A is wrong, everything is going to be wrong. So keep in mind, this is 10 meters per second. This is not a high-speed collision, okay?
Uh-oh.
You're only going 10 meters per second. A world-class sprinter can run this fast. This is not like a high-speed collision.
How many miles per hour is 10 meters per second?
Probably about 4,
Oh.
okay?
I pretty sure.
So you're moving at you're only gonna stop at 0.25 meters, which is about like, so imagine this, you're running along, boom, you're gonna stop over a certain distance. What you cannot use to find the time is distance equals velocity times time, because of the fact that this is not constant velocity, okay? What I would recommend on that one is that you use that distance equals 1/2 v plus v naught time, or if you're in triangles, it's a velocity time graph that starts at 10 meters per second.
Huh.
And it takes, that area is 0.25 meters, and you're trying to find the value of that time, okay? So if your time is wrong, everything is going to be wrong. On 13A, your time should be 0.05 seconds, okay?
Yes.
Which is not all, it's a short amount of time, but it's not all that long.
It's like one of them.
So on B, you want to figure out how much force must be exerted on the kid to stop them. So that answer should be a number times 10 to the third newtons.
Would it be negative?
Well, it would be yes.
Okay.
So it's going to be a big number, okay?
Okay.
So that's around 4,000. So then on C, what I'm asking you on C is like, okay, how much mass would that be equivalent to lifting? So this is what I want you to see. You stopping this kid in a relatively low-speed collision is like 4,000 newtons of force, which would be the equivalent of lifting about 400 kilograms. So you're going to take your answer to B, divide it by 9.8, you can get about 400 kilograms, okay? There's 2.2 pounds in a kilogram, so that's about 800 pounds. So this was the physicist's argument for the installation of child restraint seats. It was like, Mom, you're amazing, you can do all these things, you do not have superhuman strength. You are not gonna put your arm out and stop this kid from flying into the windshield,
Shucks.
because it would be the equivalent of lifting about 800
That's
pounds.
what the windshield's for.
And Mr.
Anyway.
Buckingham, they don't call me Mini Pekka for no reason.
Gotcha.
I
Anyway,
call you Mini Vic.
Yes, they did.
They call me that.
No.
on number 11, your first answer should be something times 10 to the fourth. Your second answer should be something times 10 to the third. Now, let's talk about when you get to this question out of the book, when you get to question number 4.
7, right? Oh,
Huh?
4 was easy.
Which four? The first four or the second four?
Problem 4.
Wait,
Oh, okay.
wait, like this 4?
Problem 4.
Problem 4
278.
Oh,
278.
okay, 278. Okay.
out of the book.
Okay.
Okay. So on that one, you're trying, they talk about force max. So on that one, if it's just like the same amount of force exerted over the same period of time, it's just a horizontal line. In reality, if you study forces and how they actually act, it's actually more like a triangle, where, especially on collisions, so your max force is the height of the triangle. That's this area right here. So area equals 1/2 base times height. So when they say that, oh, you have 1/2 x max, don't look at this and go, oh, that's such a weird equation. All that is we're saying 1/2 the height, your height is your F max, and the base is your time, and the area is your change in momentum, okay? So that's all it's saying. Don't look at that and go, oh, that's a new equation. It's just the area of a triangle, okay? Literally, that's all it is. We call it F max. So your answer to number 4 should be something times 10 to the third.
Whoa, number 4?
Problem 4 out of the book should be something times 10 to the third.
Did I do something wrong?
I don't know.
Probably.
what you
Wait,
have.
so the base
Hold on.
is 8 seconds, right?
No, your base is not 8 seconds. It is so not 8
4
seconds.
was
That's,
easy though, right?
That's what it says right here.
Oh, it does not.
It's two different.
So on question number 4, notice that those are not seconds. The base is milliseconds.
Oh,
Oh my bro.
yeah, that makes sense. That's pretty tiny.
So milliseconds with the times.
It clearly says milliseconds.
I can't read.
You can't listen either.
Nope.
What is this BW thing?
Oh, the Wild Wings?
That
So
would
it'd
be BWW.
8,000 seconds.
What?
Yeah,
Think about this.
Nope.
8,000
it'd be
seconds?
Point.
Smaller.
Stop.
8,000 seconds.
Stop.
That's like the orbital period of a satellite.
Stop. Hang on. That'd be like. Hang on. So if it divided by 1,000, it'd be like 1, 2, 3. So like 0.008.
Yeah.
He learned.
Now, on number 6, problem number 6, there's a couple of ways you can
6
do
is
number
right.
6. Find out how long the stone falling straight down will take to increase its speed from 5.5 to 10.4 meters per second. So, when something is falling, and this whole idea of like impulsivity. When something is falling, is the momentum changing?
Yes.
Yes, because the velocity is changing, right?
I think so, yeah.
So you can go, oh, force times time equals change in momentum. Now, when it's falling, what's the force causing it to accelerate?
Gravity.
So that would be mg times time.
Yo.
True?
So, yes.
That's what's
suppose.
creating the force.
Which question is this?
Buddy.
Okay.
Gavin.
I was writing down 4 when he was talking.
Now, that equals change in momentum, which is mass times V minus
V naught.
V naught.
Oh yeah, I didn't do it.
So do you know why they didn't give you the mass?
It doesn't matter.
Doesn't matter.
So
Cancels
they
out.
cancel out.
So you've got V and V naught, you know what G is, solve for time.
Okay, let me redo it because I did it a different way.
Now, the other thing that you could do, if you really don't want to use impulse theory, on number 6, you could go old school, V equals V naught plus GT. Elliot?
On a problem like that where it says use the impulse momentum theorem, if we used something else, would that be incorrect?
No, you're fine.
Okay,
Oh, we're fine.
so we can use other.
Yeah. Technically, that's what they wanted you to see, is that
Yeah.
impulse theory is just F equals ma. It's the same thing.
Oh, I'm gonna write it down in
So-
this.
Make sure on question 1 out of the book, okay? Question 1 out of the book,
Which one?
when you're asked to rank these in order from largest to smaller, I do greater than, I do less than, I do equals to. I do not do commas,
Oh yeah,
Oh,
okay?
forgot about
So-
that one.
What you want to do, and you want to rank this from largest to smallest. So the first thing that I should see is which one you think is the largest, okay? And then some of these might be equal, okay? But because you want to rank it from largest to smallest, let's say, for example, you think the third one is the biggest one. Okay, I'm just making up these numbers. So if you think 3 is bigger than 2, you're going to put 3 is greater than 2. But if you think 2 and 1 are the same thing, then you put a 1 there. Okay? So whatever one you rank first is the one you think is the biggest. Okay? I don't do commas. I do greater than, I do less than, I do equals to. Okay? So if you have commas, make them go away.
shucks.
All right. Anything else? We're good? And by the way, some of your answers should be negative. If you don't have any negative answers on this assignment, that's bad.
I definitely do.
Okay.
Not a
Once,
question.
twice sold? Okay,
No,
stop
I-
that camera.
A question.
What?
Number 19. 276.
Yeah?
Yeah, I don't get it.
Question 19.
I tried my best.
This might be is this about as complex
Okay.
as BW?
I guarantee you, here's what I'm guessing what went south.
No.
Look after the number 2. What does it say?
Look after number 2.
On number 19. What are the 2 letters after 2?
Is that milliseconds?
Yes. I'm guessing you just worked it as seconds.
I saw it as meters. Like meters. 2 meters.
MS,
Gabby, he might
meters.
slap you right now.
Alright, dude.
He's gonna punch
Yeah,
you again.
because throughout the past 11 weeks,
We don't.
if it was 5 meters, I put MS.
Let's just not.
Meter second.
Okay.
No.
My brain
No.
didn't read it as meter seconds first, yeah.
Yeah.
It's milliseconds.
Yeah.
See, like, he also couldn't get it.
I think if you're using something that's not
Wait,
in
where
the
you-
MKS system, you probably should write it out, but
They don't write out centimeters. They don't write out kilometers.
But those are
There's
metric.
nothing that has C.
Okay. Got it?
And then, yeah, now that we know that one, what about 7?